students, so welcome to Uniclass Academy tutorial. We're considering calculus, okay, and in this video, the topic is on integration, okay, integration, but we are not considering important rules. And these important rules is not exhaustive, as if we are not considering all the rules that are important in integration, but these are just certain of them, okay, so it's not all. Now, so as you watching, you follow along, you calculate along, listen to the explanation, okay, and then learn the concept. So the first rule that will be considered is that the integral of a sum of a finite number of functions, is the sum of their individual separate integrals. Okay, now what this means, it says that the integral of a sum of a finite number. Now, finite number is just talking about a number that you can count. Okay, finite number of functions. So that is, if you have a certain number of functions, like you can say that, okay, these are 2 functions, 3 functions, 4 functions. Okay, finite number of functions. That integral is the sum of their separate integrals. So what does that mean? Let's take an example. Now, in this example, now let's assume we have the integral of x squared plus sine x plus square root of x dx. Now, these are 3 functions of x. This is the first one, this is the second one, this is the third one. They are all functions of x. So it says that the integral of sum of finite number of functions is equal to the integral of their separate functions. Okay, so we are going to apply the integral for this, apply it for this. But remember, it's the sum. Okay, so we have plus integral sine x dx. Now take note, this sum does not necessarily need plus alone. It could be plus or minus. Okay, so it's still the same thing. Okay, so it could be plus or minus. Now we have, but in this case we have plus. Okay, so we just apply it. So plus the integral of square root of x. So in a way, just apply this integral for each of them. And so for this one now, we have x equals 3/3 plus the integral of sine x is minus cos x plus, now the integral of this is, look at, you can write it as x equals 1/2 dx. So then x equals 1/2 will now be x equals 3/2 2/3. Okay, so that's x equals 1/2 plus 1/2 plus 1. So when you solve that, is what you get. Okay, then plus c. C there is that's the constant term. Okay, so that's the answer to this question. So we can write it as 1/3 x equals 3 minus cos x plus 2/3 x raised power to give us 6 plus 6. Okay, so that's the solution to that. Okay, and then we can have another one. Imagine you have integral of cos x plus sin x plus sec, let me say, okay, let's assume we have minus plus sec square x dx. Now, so we have sum and difference. We have difference, we have plus. But that sum means sum plus or minus. So we just apply integral cos x dx. So when you apply the integral, you also put the x, okay? And then minus integral sin x dx plus integral sec square x dx. So this one gives us sin x, and then this one gives us, we have the minus sign here, so I'm using that, and then integral of sin x gives us minus cos x, and then integral of sec square x is plus tan x, and then plus 6. So this gives us sin x plus cos x plus tan x plus 6. So that law is that the integral of sum of finite numbers of functions, is the sum of their separate integrals, like this, okay? So another law, the law 2, is that a constant factor may be brought outside the integral sign, okay? May be brought outside the integral sign. The integral sign is this sign, a sign like this, okay? Now imagine you have integral of 6 sin x dx, and want to integrate it. So we can bring this constant. Constant there is like a number, okay? It could be a fraction, it could be positive, it could be negative, it could be a whole number. In this case, the whole number 6. So we can bring 6 out, and then we have integral sin x dx. Okay? So 6 here is a constant, multiplying sin x. Okay? Of course, this 6 does not have x, so it's just 6x, okay? It's a constant. So we now have integral, and then we now integrate this. So that is minus cos x, and then we put plus 3. Okay, and then we have minus 6 cos x minus 6 cos x plus 6. So the constant factor, take note, constant factor may be brought outside the integral sign. Okay, so another one is we having integral of 2x raised to power 3 dx. So the constant term here is 2. That's the constant factor. This 3 is the index, like the power of this x. Okay, so you don't bring out this 3. It is this 2. This is the constant. We have 2 x raised to power 3 dx, and then we have 2. When you integrate this, we are going to have x raised to power 4 divided by 4, and then plus 3. Okay, and then we have 2 x raised to power 4 divided by 4 plus 3, and then x raised to power 4 divided by 2 plus 6. So because 2 cancels, divide 4 rather. Okay, so another one, so that's another example there is integral of 5 u du. Now take note, this is u, this is also u. Not that you have x here and you have u here. Okay? So it's u. So well, in this case, the integration will be done with respect to u. Okay, so here 5 is a constant, so you can bring out 5, and then we have integral of 1 over u du. Okay, take note, when you bring out 5, it will be remaining 1 here. Okay, so we have equals to 5. Now to integrate this is like writing integral of 1 over x dx, and that will give us in x rather, in x plus 6. Okay, so in this case now we have 5 in u plus 6. I said in this is like writing in u, okay, plus 6. See the same thing. Okay, so this in u, this one is natural log of u. They are still the same thing, still referring to the same thing. Okay, that's natural log of this natural log of u. So this is the same thing. So this could be written as in x plus 6 and in this. Okay, so the same thing, either in x or natural log of x. So and then that's this question. So I have 5. Now, so a constant may be brought out, that has been explained. The integral of, this is another example, cos x minus 4x squared dx. Now to do this, we have like sum in quotes, plus or minus, of finite functions. Okay, so we first apply it, cos x dx, this cos x dx minus integral of 4x squared. So that's to apply this integral for each of them. Okay, so that has been done, and then we now solve this. So bring out this integral cos x dx minus, we bring out this 4 minus 4 integral x squared dx is equal to now 6 sin x, because integral of cos x is sin x, and then minus 4 x raised to power 3 over 3 plus 6. Now take note that this integration, if c is written here, that after integrating rather, if c is written plus c here, and then this one also is plus 6, there is no need to write 2 plus 6. Okay, there is no need, just write, once the whole integration is done, just write plus 6. Okay, so there is no need to write that c here and also write it here. Okay, just write one of it. Alright, so that's 6 sin x minus 4 over 3 x raised to power 3 plus 6. So that's the answer. Okay, so and then we have different ways in which the answer may be. Okay, like depending on the question rather. So another law, so 2 has been considered, 2 laws have been considered. Now the other law here, okay, the other law here is to have the addition, number 3, the addition of a constant, the addition of a constant to the variable, the addition of a constant to the variable makes no difference. To the form makes no difference to the form of the result. Now take note, what does this refer to? Now take note, it says the addition of a constant. So it must be a constant. So the variable makes no difference to the form of result. Now an example of that, recall that when we have integral of 1 over x dx, the answer is in x natural log x plus 3. Okay? Now, this now says that the addition of the constant to the variable makes no difference. Imagine you now have 1 over x plus a dx. There is a constant. There is a constant. Now, in this case, a constant has been added to the variable. Constant to the variable. Okay? So it makes no difference to the form of the result. So in this case, the result here will now be natural log of x plus a and then plus 3. So take note, a constant is added to x. So the answer will still be in this form, but in this case, it will now be plus 3. Okay? In that bracket, and it must be in the bracket. Okay? Alright, so another example of that is imagine when we have take for instance we have integral of the x over x minus 2 squared plus 9. Now this can be written as integral of 1 divided by x minus 2 squared plus 9 dx. This can be written that way. So now if you compare it, you can compare it with integral of 1 over e squared x squared plus a squared dx. This gives us 1 over e as tan x over e. Now here it says that applying this law, the addition of a constant to the variable makes no difference to the form of the answer. Okay? So that means in this case, what is added to the variable is minus 2. Okay? So we now apply it. Then that means in this case, we can write this as integral of the x all over x minus 2 all squared plus 3 squared. Okay? So we have our a to be 3. Okay? So, and then the answer now, writing it in this form, will now be 1 over 3 tan rather. Now, our x now has been added, minus 2 has been added to that x, so it's going to be x minus 2 all over 3. Now, it follows the same form. Just observe that a is from here, and then we have it here. Okay? So, that means in this we have 3, and then we have 3. And then, the addition of a constant term to the variable does not change the form of the answer. So, in this case, the variable is x, and minus 2 is added to x. So, we just have x minus 2 here. Instead of having only x, we have x minus 2. Okay? And then divided by a, which is 3. So that's the answer to that. Okay? So we take more examples. But take note, a is a constant. In this case, a is a constant. So in this case, 9 will be written as 3 squared. Okay? So another example is to have the integral of e to the power minus 2x dx. Now recall that integral of e to the power x dx is equal to e to the power x plus 3. Okay? So this way I'm supposed to have plus 2, okay? Just take note, this is plus 2. Now, okay, so I have plus 2, okay? Now, here, so we have integral of s e raised to s is e raised to s, and then we have plus 3 what that has been added. Now, to this kind of expression, what happens is to be able to integrate it, another law is going to be used, okay? And that law will be introduced now, okay? That law is that multiplying, that's law 4 now, okay? That's law 4, multiplying the variable by a constant makes no difference to the form of the result, but we have to divide by the constant. Now, what is it? Take note here. Take note. Root 3 and root 4 may be applied together. Now the contents for this video are gotten from Bondation. Okay. Now this says multiplying the variable by a constant makes no difference to the form of the result, but we must divide by the constant. Now look at this. In this case, we have integral of e raised to x is e raised to x, and then plus 2 was added. Now in this case, the variable has been multiplied by a constant. So multiplying the variable by a constant makes no difference, okay? But we have to divide, makes no difference to the form of the result, but we have to divide by the constant. Now, so in this case, the form of the result will still be in this form, okay? So here is going to be e raised to minus 2x, but we have to divide by the constant, and the constant is minus 2, so we have divided by minus 2 plus 3. So the answer here will be 1 over 2 minus 1 over 2 is minus 2x plus 3. So that's what it's saying. And the form of the answer will be the same, but divided by that constant. Now, let me add another one. Look at, we have integral of cos x over 3 dx. Now, integral of cos x is sin x, okay? And then that's plus 3. Now, so in this case, the form of the answer will not change. It will be sine x over 3 plus 3. But we have to divide by the constant. And the constant here that is used to multiply x is 1 over 3. Look at it. If I saying 1 over 3 times x, that will give you x over 3. Okay, so it will be like this. Alright, so that means, and then we have to divide by the constant. So the constant is 1 over 3. So here it will now be 3 times x over 3 plus 3. Now take note, this 1 over 3 it should not multiply x over 3. Okay? It's just dividing all of this. Okay? And that is like saying sine x over 3 like this is divided by 1 over 3. So we can write it as sine x over 3 times 3 over 1. And that will be 3 sine x over 3 plus 3. This is all we have here. Okay? Now another one is that when you have integral of dx over 2 minus x dx. Okay? Now, take note that in this kind of expression, if you compare it with integral of 1 over x dx, we have in x plus 3. Okay? So in this case, a constant has been added, but then this one is a positive x and this is a negative x. So let's just write it in this form. Dx all over minus x minus 2 dx, so that we are going to have a positive x. And then this minus can be brought out, so we are factorizing minus out. So that's minus integral dx over x minus 2. Okay? Yes, we know dx here. We already have dx 1. Okay? Now, so we have dx really dx 1. Okay, in that case. Now, so we have minus. But how did I factorize this minus? This is like saying factorize, because we have minus 1 here, okay? So it's like saying factorize minus 1. We have 1, we have 1 over minus 1 integral dx over x minus 2. So that's what this is. And 1 over minus 1 is going to give us minus, okay? That's minus 1. So now, the integral of this, okay, just that the constant is added to x, so it's still going to be of this form. That will be in x minus 2 plus 3. And that's the answer to that question. Okay, so just take note of that. And then we have, so but take note, I just want to look at this solution again. So from here to compare it to what is in the textbook. Now from here, minus was factorized, so minus 1 was factorized. We have x minus 2. Okay, take note of that. And then we have minus 1 was factorized outside. We have minus, and then we have minus here. Okay, and this was compared with this. Okay, so compare with that, so we have in, so that's it. Now another example is that when you have the integral of dx all over square root of 9 minus 4x squared. So I do not think this is wrong. In the textbook, what is written there is minus in 2 minus x plus 3. So you may verify what if the two are the same, or if one of them is more correct than the other. Now, in this case, we have, now, first compare it with integral of the x. So if you note the standard form, a squared minus x squared. Okay, and compare it with that. So when you compare it with this, it's going to give us 1 over, it's going to give us 1 over a sine x over a. Okay, and that's what that is going to give us. So here now we're going to, so since it has been compared, it's just going to give us, no, there will be no 1 over a here, so it's just going to give us sine x over a plus 6. It's arc sine rather. So let me write this again. So this is going to give us arc sine x over a plus 6. To compare with the standard form. Now, when we want to write it like this, it can be written as 3 squared minus 2x all squared. Now, so if you compare this and this, you see that our 3 is a is 3 rather, and then x has been multiplied by a constant. So the form of the answer will still be the same, but will not divide by that constant. So here you're going to have arc sine 2x instead of x, you have 2x, okay, divided by a, which is 3, okay, and then we divide everything by that constant, which is 2, and then that will not give us 1 over 2 arc sine 2x over 3 plus 3. Okay, so that's it. It was divided by 2 because that variable has been multiplied by a constant, which is 2. That's why it is divided by 2. You don't need to divide this one by 2. There's no need. Okay. So now for 3, if you have integral of cos 5a and 5x. Now we call that integral of cos x dx is sine x, okay, plus 6. So here there is a constant that is multiplying the variable, so you have sine 5x divided by 5 plus 6. So that would be 1 over 5 sine 5x plus 6. So take note of that. Now look at integral of square root of 5x plus 3 dx. Now here, if you have, let's take note that you have this can be written as 5x plus 3 is for half dx. Okay, is for half. Now, two things here. The variable has been multiplied by a constant. Okay, and that constant is 5. Okay, and then we also have this power. Okay, so imagine you have integral of x n dx is going to be x n plus 1 divided by n plus 1 plus 3. Okay, so we're going to apply that first. So you have 5x plus 3, okay, 1 over 2 plus 1 over 1 over 2 plus 1, okay, and then it says that since this variable has been multiplied by 5, okay, so we are going to divide it by 5. Divide everything here by 5. and then plus 3. Okay. Observe that in this case, this x is not multiplied by a constant. Okay. But here, x is multiplied by a constant. So that's why it cannot be written as it is still written as 5x plus 3 and plus 3, but now divided by that constant, which is 5. So what was done here is to apply this. Okay. But because the variable is multiplied by constant, it will not be divided by that constant. And then that will now be 1 over 5 times 5x plus 3. That's 3 over 2. Divided by 3 over 2 plus 6. And then it will now be equal to 2 over 15 5x plus 3 over 3 over 2 plus 6. Okay. So plus 6. So that's the answer to that question. So that's the, and the way this is done is just to say that multiply both numerator and denominator by 2 over 3. Okay. So 2 over 3. So that's going to give us 2 over 15. Okay. Now another one is when we have integral of the x all over 4 minus 3x to the power 5. Okay. Now in this case, we can write it as integral of 4 minus 3x to the power minus 5 dx. Okay. So we have 4 minus 3x to the power minus 4 over minus 4. But this variable has been multiplied by minus 3. So we say divided by minus 3. Okay, plus 6. And that will now give us 4 minus 3x to the power minus 4 divided by minus 3 times 1 over minus 3 plus 3. And then that gives us 1 over 12. 4 minus 3x to the power minus 4 plus 6. How this becomes minus 4 is to say that minus 5 plus 1, okay, that's minus 4. And then also divided by minus 4, okay? And then this minus 3 is from here, okay, because that is what is multiplying the variable. Okay, so, and then this becomes 1 divided by 12, 4 minus 3x is power 4 plus 6, okay? So, that's the answer to that question. Now, another one here is when you have integral of the x over x squared plus 4x plus 13. Now, in this case, you cannot just say the variable is multiplied by 4. What about this? This one is the quadratic expression. So this quadratic expression, write it as in form of sum of two squares. Sum of two squares. Sum of two squares. Okay. So how do we write that? Now look at the method. X squared plus 4x plus 13. Now, what you first do here is divide. Take note, this x squared must have a coefficient of 1. S square must have a coefficient of 1 to apply this approach. Now, divide. So this step now is to add and subtract the square of half the coefficient of x. Add and subtract the square of half the coefficient of x. Now, first take me, what's the coefficient of x? The coefficient of x is plus 4. Okay? So, half the coefficient is, half of that coefficient is plus 2. So, add and subtract the square of it. So, the coefficient is plus 4. Half of it is plus 2. Okay? The square of that half is plus 2 square. Okay? So add and subtract the square of that half. That's what we want to do now. So I will now say x square plus 4x, and then I will add plus 2 square. I will write plus 13. I will now subtract plus 2 square. Okay? Plus 2 square. Now this so take note, this addition, this is the subtraction. If you compute them, that will be 0. Here now we now have x. So the three of them here gives us x plus 2 all squared. And then we have plus 13 minus 4. Now take note that this 3 will give us x squared plus 4x plus 4. And if you expand it, it will also give you the same thing. Okay? So that is why they are written like that. So continue. Now, so we have x plus 2 all squared plus 9. Okay, plus 9. And then that will give us x plus 2 square plus 3 square. So it is written as the sum of 2 squares. So here we come here, we now have integral dx all over x plus 2 all squared plus 3 squared. Okay, so that's coefficient b. Okay, now if you observe this is related to that function that looks like arctan. Okay, so here it's related to 1 over a squared plus s squared dx. This is 1 over a arctan x over a. Okay, so here it will now be a is 3, so we have 1 over a. It is 1 over 3. Now arctan. Now, but in this case we have x plus 2, so it's going to be x plus 2. Okay, it makes no difference to the form, and then divide by 3. Okay, they are not dividing by 2 here because it is just an addition. It is not a multiplication, so it does not change the form of the expression. So we have plus 6, and that is the solution to that question. So I endeavor to learn how this sum of 2 squares is done. It is, write the quadratic expression, add and subtract the square of half the coefficient of x. So first look at what's the coefficient of x. When you get the coefficient of x, divide it by 2, that's half of it. After doing that, square it, which is in form of a bracket like this. Okay, even if it is negative, still put it that way. Okay, and then that means even if it is minus, you put minus here. Okay, and you put minus here also. Okay, and then you will now write the three of them like this. So if it is minus here, this will be minus. Okay, and then after doing that, you evaluate this. Okay, and then write it until you get sum of 2 squares. Okay, and you may verify if the sum of two squares gives you this. Another example here is, let me just take one example of sum of two squares. Now, the integral of du over square root of 8, this is from the exercise. Okay, now this one, write this as sum of two squares. So how to write it as sum of two squares is to have something like this. Is to have 8 plus 2u minus u squared. Now, take note, I said the coefficient of x squared must be 1. So in this case, the coefficient of u squared is minus 1. So I'll factorize minus 1 out. So that we have u squared minus 2u minus 8. So I will now solve this. Okay, keeping the minus 1 out. So I have minus 1. And then I will look at what's the coefficient of u. The coefficient of u is minus 2. Half of it will be dividing it by 2, that's minus 1. The square of that half is minus 1 square. So I will add minus 1 square and subtract it. Okay? I will add minus 1 square and subtract it. So it will now be u square minus 2u plus minus 1 square minus 8 minus 1 square minus 1 square. Okay? So it will now be minus 1, and then I have this 3 now can be written as u minus 1 all squared, then minus 8 minus 1, because minus 1 squared is 1, okay? So I have minus 1, u minus, if you verify this, you see that it will give you the same answer as this, okay? Minus 2, minus 9, okay? And then I will now have, use this minus to open it back, to open this bracket back, okay? So I have 9 minus u minus 1 all squared. Okay, so it's not take note, please. It's not in all situations that you get sum of two squares as having plus. This can be a negative, okay, but just take note that after expanding it, you must get this back. Okay, so let me expand it. We have 9 minus u squared minus 2x plus 1, and then that will give us 9 minus 1 plus 2x minus u squared, and that is the same thing as this. Okay, now come here, we now have integral du all over square root. Take note the square root is there. Is now, instead of writing 9, so I will write 3 square. This is 3 square minus u minus 1 all squared. Okay, so that will be minus u minus 1 all squared. Okay, and that will not give, if you compare it with the s all over square root of a square minus s squared. That will give us arc sine x over a. Okay, so here is going to give us integral of, excuse me, there will be no integral again, so that will just be arc sine. Our x now is now u minus 1, so u minus 1 all over a, which is 3 plus 6. Okay, so that is the answer to that question. Okay, so that's the answer to that question. Alright, so is depending on the way the question is that will determine what form the answer should be. Okay, now take note, before I going to close, take note of that. Take note of this integral of f of x is equal to in of f of x plus c. Now, what this means is that the integral of a function of this form, here we have f of x, here we have f prime of x. If you have something like this, that is, you have a function f of x, the derivative of that function is what is on top here. Okay, in that case, if you have such an integral, the answer will be in of f of x. In of f of x. An example is that integral of sin x, we have cos x divided by sin x. Now, if you look at it, observe this as f of x. The derivative of f of x, so if this is f of x, f prime of x is cos x. Okay? Because when you differentiate cos x, you are going to have, when you differentiate sin x, you are going to have cos x. When you differentiate f of x, you are going to have f prime of x. So the derivative of sin x is cos x. So in that case, the answer will be in of, that's natural log of sin x. In natural log of f of x. So that's the integral of this function. Now, more example on that is when we have integral of cos cube minus 1 and 4x cubed minus 1, x raised to 4 minus x plus 2 dx. Now, if you look at this, first look at the side is this function, the derivative of this function, when you differentiate it is 4x, when you differentiate it is 4x raised to 3 minus 1. And that derivative is what we have here. Okay, that means this will now be natural log of x raised to 4 minus x plus 2 and then plus 6. Okay, so that's about that. Now another one, when you have integral 3x squared divided by x raised to 3 plus 1 dx. Look at this function. If you differentiate it, you are going to have 3x squared. And this 3x squared is what we have at the numerator here. So therefore, the answer here will be natural log of x raised to 3 plus 1 then plus 6. Now another one, there may be instance where that you have to do a little adjustment. Now look at this. Look at integral e raised to power 3x over e raised to power 3x minus 1 dx. Now if you look at this function, you observe that the derivative is 3e 3x. When you differentiate this one is 0. So, but when you differentiate this, it's going to be 3e 3x. Okay? Now, this derivative is not exactly the same thing as what we have here. Okay? Because of this 3. So, what we are going to do is to adjust this function, this question itself. Okay? We cannot write it as, because it's 3 that we need here. We need 3 here. So what we do is that we will multiply it by 3 and also divide it by 3. Okay? We will multiply it by 3 and also divide it by 3. So that question will now be written as 1 over 3, 3e 3x over e raised to power 3x minus 1 dx. What we did here is like saying that we multiply by 3 and also divide it by 3. Okay? Because we know that we need, because 3 is needed here. Okay? So the question has become, as is now written as this. Okay? So the question is written as that. And then we now have 1 over 3. So that this one now, the derivative of this is now exactly this. So the answer is 1 over 3 natural log e raised to power 3x minus 1 plus 6. That's the answer to the question. Okay. Now another question is integral of x plus 1 divided by x squared plus 2x plus 5 dx. Now, if you look at this function, if you differentiate it, you are going to have 2x plus 2. But 2x plus 2 is not exactly what we have here. The difference is 2x plus, is like writing like this. But when you factorize this, you are going to get this. Okay? So now we have 2 times x minus 1 in bracket. So compare it with this. You see that the difference is 2. Okay, is this 2. So therefore, let's adjust this question so that we can write it as 2 divided by 2. Okay, x plus 1, x squared plus 2x plus 5. Okay, dx. So this 2, I will bring it inside so that it can be written as 2 into bracket this. Okay, so this question is now written like this. Okay, now so we have 1 over 2. Now this one, now the derivative of this is exactly what is on top here. Okay, so I can write as integral 2x plus 3 all over x squared plus 2x plus 5 dx. So the answer will now be 1 over 2 natural log of x squared plus 2x plus 5. And that's the solution. So one more integral of the x all over x natural log of x. Now, if you look at this kind of question, we may write it can be written as saying integral of 1 over x divided by natural log of x dx. Do the same thing. Okay, because if you simplify this, you write it. If you simplify it, it's like saying 1 over x divided by natural log of x. Okay, so it will now be 1 over x times 6 over 1 times 1 over natural log of x, and this one is the same thing as what we have here. Okay, okay. We can now have, now if you look at this, the derivative of in x is 1 over x. Okay, derivative of in x is 1 over x. So that would be the answer to this question now is in of f of x. So that's in of in x plus 6. That's like writing in of in x plus 6. So that's the answer to that question. So bring it to a close here. This is Venus Class Academy. This is Venus Class Academy. If you have questions, you may ask. Either call or text or send message on WhatsApp to this number. Thank you for watching. Bye for now.